Alright, welcome to today's class. In today's class, we'll be dealing on dimensional analysis. What is dimensional analysis? Dimensional analysis is a method used to determine the exact relationship between two or more physical quantities. Alright, let's solve an example. Example 1. A simple pendulum has a mass m attached to a string of length L and is at a place where the acceleration due to gravity is g. If the periodic time of swing t of the pendulum depends on m, L, and g, find a formula for t in terms of m, L, and g, which is dimensionally consistent. So in this question, we are asked to find a formula that relates t, m, L, and g together, and the formula must be dimensionally consistent. Now take note of this. In the question, we are told that if the periodic time of swing t of the pendulum depends on m, L, and g. So we are told that the time depends on m, L, and g. And in mathematics, if a term depends on another term, you simply use proportionality sign to show it. So we are told that t, which is the time, depends on m, L, and g. So t depends on m, L, and g. Alright, so our next task is to introduce superscript. So therefore, t is proportional to m raised to power, let's use ABC as the superscript. So we have m raised to power a, and then multiply by L raised to power B, and then multiply by G raised to power C. So ABC are the superscripts. Now remember, the reason why we have proportionality sign here is because T depends on M, L, and G. The proportionality sign shows that t depends on m, L, and g. So our next task is to introduce a dimensionless constant. Introduce a dimensionless constant. So dimensionless So if we introduce a dimensionless constant, let's say k is the dimensionless constant. So if we introduce k into this equation, it becomes t is equal to k multiplies m raised to power a, and then L raised to power b, and then g raised to power c. Once you introduce a dimensionless constant, the proportionality sign turns to an equal sign. So this proportionality sign turns to an equal sign since we've introduced a dimensionless constant. Alright, so let k be equal to 1. K is always equal to 1. Take note of this. K, which is the dimensionless constant, is always equal to 1 unless otherwise stated. Unless it is stated in the question. But k is always equal to 1. So if k is equal to 1, therefore t is equal to m raised to power a, and then L raised to power b, and then g raised to power c. All right, so our next task is to find the dimensions of the parameters. The dimensions of the parameters. Here we have t. T stands for time or period. So we have period. So period is t or time, and time is capital letter T. It is a fundamental quantity. Time is capital letter T. And also we have mass. If you check the question, that's why we have M here. M stands for mass. Mass is M, capital letter M, and we also have length. Length is capital letter L. Now this is the question. Let's confirm. A simple pendulum has a mass M. So mass is here, attached to a string of length L. So we have L, which is length, and is at a place where the acceleration due to gravity is g. So g is the acceleration due to gravity. If the periodic time of swing t, so we are also given periodic time of swing, which is t. So what's left? We have acceleration due to gravity. Acceleration due to gravity, and acceleration due to gravity, g, is equal to, the formula for acceleration is velocity all over time. So we have velocity all over time. So acceleration is velocity all over time. So it is equal to, velocity is displacement all over time. The unit of velocity is Lt raised to power -1. And then all over, time is seconds. So we write here capital letter T instead of S. For you to have a better understanding of this concept, kindly check the description of this video and you will see a link to derived quantities and derived unit. Watch the video on derived quantity and derived unit and you will understand this concept very well. So this is equal to, if you move the denominator upward, it will become Lt raised to power -2. So therefore, acceleration due to gravity is equal to Lt raised to power -2. All right, so our next task is to substitute the dimensions. So we are going to substitute the dimensions into this equation. T equal to m raised to power a, and then L raised to power b, and G raised to power c. So we have T is equal to m raised to power a multiplied by L raised to power b multiplied by G raised to power c. So let's call this equation 1. So if we substitute their dimensions, we would have T, which is the period, is capital letter T. So it is equal to the dimension for mass is m. So we write capital letter M and then raised to power A, multiply by length is L and then raised to power B, multiply by the dimension for acceleration due to gravity is L t raised to power negative 2 and then raised to power C. Alright, so our next task is to apply the product power law of indices. So we have a T is equal to M raised to power A multiplied by L raised to power B and then multiply by, if you apply the product power law of indices here, you will simply use the outer power to multiply the inner power. So C will multiply the power of L and then C will also multiply the power of T. Now remember that L is raised to power 1. L is raised to power 1 here. So C multiplied by 1 is C. So therefore L becomes raised to power C. And then multiply by T raised to power negative 2 multiplied C. It becomes negative 2C. Alright, so our next task is to collect like terms and then apply the multiplication law of indices. T is equal to M raised to power A, L raised to power B, and L raised to power C. They are the same base but different powers. So we will apply the multiplication law of indices by simply adding their powers. So we have L raised to power B plus C. If you want to learn how to apply the laws of indices and what indices mean, kindly check the description of this video and you will see a link to our tutorial on indices. So we have T raised to power negative 2C. Alright, so our next task is to compare index or compare power. Compare powers. Alright, so let's start with T. So for T, to compare the power, you will have to equate the powers of T at the left hand side to the power of T at the right hand side. So for T, the power of T at the left hand side is 1. So we have here 1 and then equal to the power of T at the right hand side is negative 2C. So we have negative 2C. Now for M, we will have to equate the powers of M. We will have to equate the power of M at the left hand side to the power of M at the right hand side. So if you check the left hand side, there is no M here. So the power there is 0. So we have 0 equal to, at the right hand side, M is raised to power A. So the power of M is A. So M is A. And finally, we have L. If you check the left hand side, there is no L. So the power of L at the left hand side is 0. It is equal to, at the right hand side, the power of L is B plus C. So we have B plus C. So this is how you compare index or compare powers. So let's call this equation 2. And let's call this equation 3. And let's also call this equation 4. From equation 2, we have that 1 is equal to negative 2c. So to make c the subject formula, simply divide both sides by negative 2. So we have 1 divided by negative 2, and then negative 2c divided by negative 2. So this cancels this. So therefore, c is equal to negative 1 all over 2. So this is the value of c. Alright, so our next task is to substitute the value of c into equation 4. So let's substitute c into equation 4. So we have here 0 is equal to b plus c. So this is equation 4. So if we substitute the value of c, we would have 0 equal to b plus minus 1 all over 2. So this gives us 0 equal to b plus multiplied minus is minus. So we have 1 all over 2. So therefore, b is equal to 1 all over 2. From equation 3, a is equal to 0. From equation 3, let's confirm. This is equation 3. This is equation 3. 0 equal to a. Therefore, a is equal to 0. So a is equal to 0. B is equal to 1 all over 2. And then c is equal to minus 1 all over 2. Alright, remember that t is equal to m raised to power a multiplied by l raised to power b multiplied by g raised to power c. Remember that this is equation 1. So if we substitute the value of a, b, c, it would give us t equal to m raised to power 0 multiplied by l raised to power 1 all over 2, and then g raised to power negative 1 all over 2. Therefore, t is equal to, now m is raised to power 0. According to the zeroth law of indices, any number or base raised to power 0 is 1. The zeroth law of indices states that apart from 0, any number or base raised to power 0 is 1. So m raised to power 0 is 1. So we write 1 and then multiply by l raised to power 1 over 2. And then multiply by g raised to power negative 1 all over 2. So t is equal to L raised to power 1 over 2 multiplied by G raised to power negative 1 over 2. Now take note of this. If T is equal to G raised to power negative 1 over 2, T is equal to, now G raised to power negative 1 over 2 means 1 all over G raised to power 1 over 2. Let's take another example. So if we have 3 raised to power negative 1, it is the same thing as 1 all over 3. Or if we have 5 raised to power negative 2, it is equal to 1 all over 5 raised to power 2. So therefore, T is equal to L raised to power 1 all over 2 all over G raised to power 1 all over 2. Alright, take note of this. 4 raised to power 1 all over 2 is equal to square root of 4. 9 raised to power 1 all over 2 is equal to square root of 9. Alright, so before we continue, if you've not subscribed to this channel, kindly subscribe now. And then if you have a question, simply leave your question in the comment section. Ensure you like this video. So therefore, we have T is equal to L raised to power 1 all over 2 all over G raised to power 1 all over 2. So therefore, T is equal to square root of L all over square root of G. So therefore, T is equal to square root of L all over square root of G can be written as square root of L all over G. So T is equal to square root of L all over G. This is our final answer.